Welcome back. This one's supposed to have a higher amperage. This one's only like 200 milliamp hours or milliamps. And I tried it out with my bucket and hose setup and I only got like 9 volts. I need to increase the head on my system, which I can do right now, but in a month or two there probably won't be enough water for that to be viable. Right now I have a bucket here, and this is going to be our filter bucket, where I'm going to put a bulkhead fitting in here and drill a bunch of holes, and this will filter in water from the stream so then it can go to, I'm going to take this off, to one of these guys, but a bigger one. This is 1/2 inch. I have 3/4 inch water line that I'm going to use. I just traced out this on here and I have to cut it out. I got that in with there's a rubber gasket in there that goes there. And tighten this up a little bit more. There, that should be watertight. Not that that matters a whole lot for this. It's not going to be under high pressure. And there should at all times be an overflow. Now the theory goes, if you can't, you see that? Come on. Anyways, in here there's a smaller diameter restriction, and my theory, or the theory goes that if you filter it with a smaller diameter drill bit than your nozzle, then the nozzle, you're not going to have any clogging issues. So now I just have to pepper this thing with hundreds or thousands or millions of little holes. Alright, now I've absolutely peppered this with holes all the way around on the bottom. And we'll go put it in the creek. I also have to put on a overflow, and I'm going to accomplish that by using this piece of pipe, and it's going to go on the bottom, with the bottom of it, you know, resting on the bottom. Well, not quite resting, but just above the bottom. So any silt that does collect gets sucked up with the overflow. And then on the outside, I'm going to put this little piece of pipe here. All right, here's the overflow, and that's what it looks like inside. I decided not to put this on there because, you know, just stick out a lot, but that's fine. Okay. You can see the fence there, that's the property line, so I'm going right below it. For size reference, here's a shovel. And you can see it's flowing a bit down there. And I expect in a month or two that this will be dried up. But I'm not sure. It depends on how much it rains. This is spring fed from a spring way up there. And during the summer, all of the foliage vegetation will soak up all of the water that the spring puts out. And this is, you can see my other filter box down there. And it's going down to right there at the tip of my finger. I don't know what the flow rates are or the exact head height. I estimate the head height to be about 15 feet. And flow rate maybe 3 gallons a minute. So I'm not expecting much power from this. It's more like creating content for you guys. We can see all the water flowing in here. There may even be some spring action. I see water flowing in a lot of different places. I don't have a hose or the water line hooked up to this yet, but that'll go something like that. And then the water line will come out, and I'm going to have to just pack mud around it or whatever, just to seal it up. So the water line's gonna have to come through this dam here. And then on its way down, I do now realize that I need to put the bucket lower, because it's not, I mean, it's going to overflow this measly little dam here before it hits the overflow in the bucket. So I'd like to make it so that the overflow handles all the water, or at least a majority of it, so there's no impetus for the water to go over or through the dam. So I need to dig it out some. That's a little better. I might need to move the overflow down a little bit. Here's that roll of 3/4 inch pipe that I can use. We were going to use most of this for the house. No, you guys don't care. Alright, this has 3/4 inch thread on the end of it, and this will thread right into that bulkhead fitting. So I need to unroll this, which I'm not too thrilled about. You can see other hoses that I have around here, because I actually use this creek water to water my garden for the first half of the summer. I had to go to the hardware store. I got this is going to go at the top. This threads into the bulkhead fitting, and then I have a union and the barb connector. At the bottom, another barb, a shutoff, and then another union. And this is so that I can disconnect the turbine and not have to deal with any of the other piping. I have the other end of this where it needs to be approximately, so I have to cut this end off about here. Also with the union, I can connect this up here out of the stream. Oh, crap. Undo, undo. Okay, undone. I have these Apollo cinch clamps. It'll go on here. Probably need two, but none of this will be high pressure, so I'm not concerned about needing to. Now I can hook this up to the bucket, taking care to not lose this O-ring, which isn't coming out on its own. Okay, I'll stick this in my pocket. And here we can see the water's going in. And there's little, well, when I put my hand on it, little bits of like rings, turbulent rings, whatever they're called. So on goes the slip ring. On goes that. The cinch ring in there. So I shut that off. I'm going to let the top purge of all the air bubbles. And I'll come back later and install it. Alright, I have a few comments to make about what I did here. So when I was putting in that overflow, I don't know what I was thinking. Of course, you can't just leave the overflow pipe like that if the bucket's filtering water. You know, the pipe has to leave through the dam. So I'll have to put a piece of 3/4 inch PVC on there to bring it out past here. The second is, I know I shut off the valve down there to build up water up here to purge the air, but that's not the correct way to do it, so I'm gonna fix this into the correct way, and that is to get rid of any rise. Like right there, there's a rise. So I need to tamp those down, you know, rocks or something to weigh them down, because bubbles will still form out of the water, or the water will drag in bubbles, or, you know, whatever. And then you'll have an airlock, and it's not going to flow properly. So I need to take care of those now. All right. That's bubbling because I fixed the slope, and when I had turned it on at the bottom just now, it sucked in air. So I think two things. I'll need to make I guess one thing. So one thing, I'll have to make a intake pipe that screws into that's 3/4 inch threaded on the inside of that bulkhead, that has holes in the bottom, so it will suck only water and not air. And all this bubbling shows that it is properly, well, there it stopped. So it's properly sloped the whole way. So I have it hooked up here, and we're going to see how many volts it makes. I know volts isn't everything, but as long as we have a minimum amount of volts, it can be regulated down to charge like a 12 volt battery, which is what I consider the minimum for a useful power source. Now, of course, you could charge like lithium batteries, but 12 volt lead acid is where it's at least for now, for what I'm doing, because I have a lead acid battery already. I've already tested this, and I'm going to turn it on so you guys can hear it running. And you're going to have to guess how many volts it gets. In the next video, I'm going to be going over how efficient it is and comparing this one to my other larger turbine. But the person who guesses closest to the 10th of the lowest digit that it ever shows here, you're going to win one of these turbines. Not this one, but a brand new one. So leave your comment down below with your guess to the nearest 10th in volts, and I'll see you in the next video. we got a stick. I don't know where that came from. That's interesting.